So,
Started. Hello everyone. Welcome to the first track session in fast delivery track. So today we are going to have a discussion in this session on containerization, aha and oops moments by Vivek and Kamal. Right. So if I want to introduce our speakers, Vivek is an author of a book named Blameless Continuous Integration, a practical guide with concepts from DevOps and social psychology. He is also running Vivek Chronicles, a newsletter which takes the readers out of his journey of agile and DevOps experiments. He has spoken in many public speaking conferences on DevOps, especially on DevOps. Now, if I want to introduce Kamal, Kamal is a problem solver, quick learner, mentor, and a seasoned developer. He is also open sourcer. A lot of open source code he has in his repository, about 36 repositories he manages. And he has an experience of about 11 years in terms of architecture, design, developing a software products. His strength lies in Java, JavaScript frameworks, REST APIs, and Spring frameworks. So, and also he is very well versed in CI/CD. Hi, Vivek and Kamal. Over to you. Stage is yours.
thanks, Albert. Thank you for the introduction, Albert. Okay. So good that we got done with the introduction part. So now we can directly dive into the session in that case. So what we are going to do today is this session is going to be experience sharing session where we are going to share some of the experience. And also the prime motto of this session is to save you time and thereby saving you money. Right? That is the prime motto. How are we going to save time for you? We are going to share whatever mess ups we did. We are going to share what mistakes we did. And also, we get a chat saying it's not working.
I will handle that.
Okay, fine. Yeah. So we are going to share what mess ups we did. At the same time, we are also going to share some aha moments we got. When we are currently working with a product, face recognition product, FaceQuest.io. So with me, Kamal is there. Myself and Kamal are co-architecting or co-creating this platform with an engineering team. So let's dive deeper. This is totally going to be about containerization, and we will also have it's not going to be a very advanced session. It's going to be a beginner friendly session. We are going to add some concepts if you do not already know anything about containerization. So let's get started. So we are in a conference which is called Technical Agility Conference. Now, before we get anywhere, I just wanted to give a context of what is technical agility so that, everybody is on the same page and we can connect what we are talking to the theme of the conference. So before going into technical agility, I wanted to say what is agility. Agility is not a process. Agility is not about Scrum. Agility is not about just doing 4 or 5 meetings in a week. Agility is just the quality of nimbleness or just flexibility where you can change based on whatever external situations change. That is agility, and that is the definition of agility that we will be using for this talk also. And what we are going to get into technical agility is we all have business. Business needs technology to survive. Today's businesses are mostly driven by technology, right? And what we are looking at is business needs to be agile in order to survive in the market. And the external conditions that challenge the survival of the business may be competitors. It may be a situation that is beyond their control, very much like this COVID-19 situation. And how the business responds to such things decides whether a business is surviving or it is not surviving. And most of the businesses have technology as a driver. So businesses need technology. So if you are targeting business agility, then technical agility is a need, where because the technology and the underlying technical processes, even collaboration, everything has to be optimized in order to actually get a business into an agile state. Now, this is the context of technical agility that we want to start with. But when we talk about technical agility, what are the predominant areas? We are all in TAC 2020. I just shamelessly stole this from the TAC 2020 website. This is the basically 3 pillars of technical agility. So if you want to, if you're interested in knowing what is technical agility, just go to this website's homepage and you can directly see what these 3 things are. So these revolve around culture and collaboration, then product stability and reliability, fast delivery, which is time to market. These are the 3 levers of technical agility. So our talk is currently based on fast delivery, time to market because of the containerization part, but we will also touch upon areas of quality and collaboration in this talk. So this pretty much covers the introduction of what we are doing in this talk, and I will let Kamal give a nice introduction about containerization. Over to you, Kamal.
Hey guys, so I hope I'm audible. If not, you can let me know in the chat. All right. So yeah, so let's start to understand what is containerization by discussing what is not a container, right? So most of the people think container is a virtual machine, right? So it is not a virtual machine basically, and few argue that it is a lightweight virtual machine, and that is not the case as well. So they both are similar in their goal to isolate the application and its dependencies to run on a self-contained unit and which can run anywhere, right? So that is a similarity, but it differs in the architectural approach. So let's try to understand what is a virtual machine, right? So the basic building block of a virtual machine is the infrastructure, which is your laptop, or it could be your server running in the data center, or it could be some server hosted or a EC2 instance or a DigitalOcean thing, right? And we need an operating system, which is the whole interface that is running on the infrastructure, so that we can interact with whatever is provided by the server, right? And there is something called hypervisor. And this is the engine which interacts with the host operating system in order to provide the virtualization for the virtual machines that run on the infrastructure, right? So in order to make it clear, right? So let's assume we have a laptop. We have an operating system running on the machine. It could be Windows, it could be Linux, it could be Mac, right? So in order to run multiple virtual machines, we need to enable something called hypervisor, and then virtual machines can run on top of it, right? So what hypervisor does is it provides hardware virtualization to the guest OS, right? So in order to deploy applications, we would need the application dependencies. So if in the case of Java, we would do Maven dependencies. If it is in the case of Node.js application, it would be NPM packages, or in case of Ruby's, it could be gems. So these are the dependencies for the application we would like to run. And there is the next layer, which is the application source code itself. So if you see in this case, there are 2 virtual machines which runs 2 applications independently. And somebody says I'm not able to join. Okay. Yeah. So this is about virtual machine, right? And now let's try to understand how it differs from a container. And a Docker container is not a silver bullet. So basically, it also needs an infrastructure. Let's assume for simplicity, we are running in our laptop, right? We need an operating system, could be Windows or Linux. And instead of a hypervisor, we have something called Docker daemon. So this is the service which interfaces with your host operating system and lets the container to run on the host operating system. Basically, Docker containers do not have its own independent OS. It shares the host operating system. So earlier in the case of virtual machine, we had guest OS. For each and every virtual machine that we run, we had an overhead of guest OS. So typically, guest OS consumes about like 700 MB. In our case, we had 2 different VMs. So it could be like 1.4 GB of memory, plus it also needs computation power and the memory or a disk to run the VMs, right? So these are some overheads which doesn't exist in our Docker container. And because of that, it is very lightweight and it is easier to use. We can use it, or we can scale it very easily. And in case of VMs, it has its own overhead. So I think you can see the difference between the VM and versus the containers here, right? let's move on to, yeah. Vivek, you're on mute, I think.
Oh, sorry about that. We are done with setting the context. We started with what is technical agility and the containers part. What is a container? So now we want to explain you, before getting into the aha and oops moments, why FaceQuest needed containers in the first place, right? So FaceQuest, as I told before, is a face recognition as a service. It's a software where you can just upload some reference faces, and using an API or UI, you can find out who is in a given picture. That's the one-line description of FaceQuest. And it has multiple applications, which we'll not get into right now. But given this context, what we do is we have our own classification service, which is going to find out which face belongs to which person, and that is running in a separate infrastructure. And we have our own APIs. For all these things, we needed something in order to host this code. That is why we were looking at multiple options on where to host the code of API, where to host the code for the core face recognition service, and all these things. So when we got into this idea of finding where to host, we found containerization to be a very powerful driver. And what drove containerization for us? There are three things that drove containerization for us. One is need for focus. Need for focus as in, we did not want to concentrate on managing unnecessary infra. We did not even want to concentrate on managing OS in the VMs that we are running on. We did not want to concentrate on network issues that may come because of the misconfiguration of routes and multiple things. So containers basically gave us a small capsule which can just take our application code and just run it in any environment that we want. That way we focus only on our business, which is creating FaceQuest. We do not focus on network issues. We do not focus on any other technology issues which come from operating system or the network layer. We just focus only on our application. So need for focus was the first driver. Second driver was cost optimization. We wanted to run with as less cost as possible. Ampiat is a startup. If you don't know, FaceQuest is a product of Ampiat. Ampiat is a small startup, and we do not have that much money like big guys. And we want to run with as slick infrastructure and as less cost as possible. So containerization provided us cost optimization, which Kamal will soon explain when he explains the aha moments. That's one of the drivers for us. Third driver for us for containerization was quality. Quality as in, we do not want any issues which start from, oh, it works in dev environment, but it does not work in prod environment. We do not want anything like that. What we do is, whatever works in our container in the dev environment, the same setup and the same container is going to go into prod environment. So we anticipate very less issues because of this mismatch between node versions that are different, and maybe software OS versions that are different, and multiple other factors which make you pull your hair whenever you debug these kind of issues. So these are the predominant drivers for us as to why FaceQuest.io needed containerization as its core infrastructure and platform choice, right? Let's move on to aha moments, and Kamal will share you some good things that we had when we were developing FaceQuest. Over to you, Kamal. You're on mute, Kamal.
Sorry, can you hear me?
Yes.
All right, yeah. Let's try to enjoy some aha moments which we encountered while building FaceQuest, right? So, yeah, as Vivek nicely explained, we were trying to explore multiple cloud vendors in order to host bits and pieces of our application, right? So this is what we found. Cloud vendors love containerized apps. So this can be illustrated basically by 3 points, right? So while we were exploring, we found that AWS rewards fault-tolerant application. Basically, a fault tolerance is nothing but an ability for the system to run in spite of failures by the parts of the component in the application, right? So AWS rewards it by reducing the cost of the infrastructure that you run, basically by providing a service called Fargate Spot. So FaceQuest has been built as a fault-tolerant application from the ground up. So because of this fact, we were able to leverage Fargate Spot, and we were able to get 15% less cost than using VM. If we were to use VM, right? It would have costed like 15% more. And on top of it, we had to maintain the server by ourselves, and we don't want to do it. So yeah, this goes back to Vivek again, right? And also, additionally, we get the cost even more optimized by auto scaling approaches, right? So let's assume we have the scaled application and we have fixed like 10 EC2 instances to handle the load, right? We would never be able to predict when the load increases or decreases, right? So if we were to use EC2 and we had 10 EC2 instances to handle the load, we would have incurred fixed cost for a month if we take 1 month as a period, right? But in case of this Fargate spot, right, we can easily scale up or scale down based on the demand, and it automatically does it, right? So that is the beauty of the containers, right? You can scale multiple containers based on the need.
One more thing to add to what Kamal said, this 15% less cost, think of it as a discount for doing good design in your application. AWS gives you a discount of 15% if you do a good design for your application, where anything can shut down anytime, but still the system will work properly. That's the advantage you get here, right? So over to you, Kamal, again. Next, I'll just move to the next slide.
Yeah. So for the moment too, yeah. I'll give you a few seconds to go through this conversation, right? So this piece of conversation shows you a conversation between a manager and a developer, right? So try to understand what has been going on. Right, sounds familiar. So this conversation has been a joke, right? Whenever a developer says, okay, something works on my machine and there is an issue in the production, right? So somebody tried to make this joke a reality. So now you can ship your development environment to the production. Actually, it can be shipped to the customer. So that's the power of the container. Whatever you have in your local is what is in the production, right? And moment number 3, right? So when we were building FaceQuest, right? So we had some bits and pieces or some part of the application which doesn't run in the non-HTTP port, right? So we were trying to run it in the container, and we were trying to see if that particular piece of software is running or not, and we were trying to break our head. So when you use Docker containers, right? So there is a tool which you can use called Kitematic. And this offers a cool feature where you can just see what is being deployed, and it automatically shows you the preview. Like this was a lifesaver for us. We were wasting so much of time, and we realized, okay, this is running, and it has been running in a non-8080 port. And yeah, Vivek would fill you the oops moment, and you will understand furthermore the context of what has been happening, right? Over to you, Vivek.
Yeah, so Kamal told all the good things that we did, and happy news. I am here to tell you how we messed up, right? And I'm going to share all the embarrassing things that we did so that you don't do them, so that you can save some time not doing such stuff. We wasted hours and hours of time, sometimes, weekends, a lot of hair pulling. So let's see. So the first before we get into my oops moments, right, I wanted to share some context so that you understand the oops moments well. So given that, beginners might be joining this session, we also created an open source repository which you can actually download and play around. Shortly we will talk about it, but I'm going to show you a demo application, and this demo application has a very simple requirement. It has to show a web page which says hello world. And if it is running in dev environment, this should say hello world, this is dev environment. If it is running in a prod environment, it should say hello world, this is prod environment. Very simple requirement. Not a lot of dependencies to it, but this itself can create a lot of, oops moments that we can explain, right? So this is basically our expectation of what our demo application is supposed to do. And how did we go about designing this demo application? Right? What we did was, our solution for this requirement was, we will have a container, and inside that container we'll put our Node.js based server, right? And this Node.js based server will serve a web page which has, URL should be different. Yes, that's true. We have a same deployment. I will show you that setup. Yeah. So Node.js based server is going to give you a HTTP server, and anybody can access from that port that it opens. That's true. So now, how did we get to this? what we did is we have a sample code which you can get from this URL, right? And it has a folder called src. This has the source code that would go into this Node.js server. It's a very simple bare bones Node.js application which just serves an index.html file, right? And this is what we have in our Docker container. And also, if you see, this src folder, of course, contains code, the source code that is going to run from the server. And Docker file is basically the file which contains instructions on how to build a container. So the inner green hexagon is coming from the src, but the outer box on what should be the components of that box comes from the file called Docker file. Right? So what I will do is I will show you an example of how to build our Docker container, what steps we did in order to build our Docker container. This may differ for different applications. This is just for our demo application. So the first step, we have 4 steps to build our Docker container. We pull something known as a base image. So think of it like the base on which your application is going to run. So you need a base on which your application is going to run. And there are a lot of open source base images available over the internet in a site called Docker Hub, right? What you can do is go to Docker Hub and you can just start looking at how many different base images are there. So what we do is we pull any Docker image with Linux and Node.js support. That's the first step. Whatever we are writing here, I will show in the Docker file next step, right? So then install the Node.js dependencies for my application. I'm using a server called Express.js, so I'm just going to install that in the npm node package manager since it's a Node.js server. And then I'm going to just copy my source code folder into the container. And fourth is expose support 8080. This is basically a very high level, but not so accurate. But yeah, it gives you a very good high-level overview of what you're trying to do here, right? So now I will show you an example of a Docker file. This is basically for beginners who may not have seen a Docker file before. So this is also a possibility of how to create a Docker image, image of your application. So what we do is we have a base image. I call this Node 10 Alpine. This is I found in Docker Hub, so I can directly take it. This supports Node.js, right? And there are multiple sections that we want you to pay attention to. There is a command called run that you give in Docker file, which is nothing but it runs a Linux command, right? And this command is run within the container. So you are building a container, and within the container, you are going to run the command that, if for example, this line runs, run mkdir, make a directory called home node app. That's what it's going to do. Then the second command that I want you to pay attention to is the copy command, which is nothing but, as it says, copy something to inside the container. So it's going to copy the source folder here, src folder, to whatever is the current folder inside the container, which is nothing but the work directory. For example, here we created the work directory, make directory inside the container, and declared that the current work directory is the directory that we just created, right? And this copy just copies your src folder to this thing, right? Now, after that, you have something known as env command. This is a representative doc file. We have taken out some of the sections of the Docker file. So don't think that this is a full Docker file. In order to show you the commands, we have given only some sections. Don't worry about it. So env is to set an environment variable. So these 3 commands actually contributed to some of the mess ups that we did. That's why I'm focusing on these 3 commands, right? So let's get into what we did. Who's moment 1? I told you the run command is to run a Linux command, right? So what I would expect is I should be able to run a command called cd to change directory, so that I can do very much like a shell script. So my mental model is I will take a shell script file, and every line in the shell script file, I'll prepend it with the run and copy paste into the Docker file, and it will run like it runs in a shell script, but just that it should run within a Docker container. That's what you would expect. So you would do something like this: run cd home app. So you changed into this directory, and let's say this prepare.sh is within this app directory, and you would say run /prepare.sh. So if you just hide this run part, this looks like a shell script, perfect shell script. Remove the run here. But this will not work like expected, and we're stuck for a very long amount of time to understand why this will not work, because we did not understand Docker properly. And beginners like us can get into a situation where you will not be able to understand Docker perfectly, what you are supposed to do in order for it to work is something like this. So each run command is a independent unit of its own. You cannot just like that add run commands and make it start working. So instead of writing like this, you should write in a single run command, you should write cd also, followed by ampersands, and then this. And not knowing this cost us at least 4 to 5 hours of work and a lot of high stress during the times where we want to actually build a quick prototype for our application. And this could be avoided when you probably know one simple fact that run command is independent and each run command is on its own, and wherever it runs from the working directory of the Docker. Once you know this, there is another command called copy that we spoke about. Copy also copies things into the working directory only, nothing else. So that is also another aspect of it. So this was the first oops moment. So I gave you 5 hours of our time so that you don't do this again. That's what we are doing now. Now let's go back to the second oops moment. This is also about the same commands in the Docker file. Another misconception. So there is a command called expose that comes in Docker file. Okay, the way you look at it, expose, oh, it's going to open a port in Docker, 8080 port is going to be open whenever I run this Docker file. That's what you would think. But bad news, this doesn't really do anything at all. There is no code written inside Docker to handle what this is. This doesn't do anything. This is just a documentation piece. You could as well comment this line and no difference would be observed. We were just trying to expose a port using this and seeing 8080 port in the Docker container. Nothing was coming up because this is not what it suggests, right? This is so the counterintuitive part of, I don't know. This is just a documentation piece. It has its own benefits. It's not that it's useless. It has its own benefits. For example, you got a Docker file from somebody else. You could easily find out what ports they're exposing from their application just by looking at this command. So this is not talking to the Docker. This is not talking to the computer. This line is supposed to talk to the human being who reads the Docker file, this expose, right? Now, if you really want to expose your port, what you should do? After building the container, you are supposed to run saying Docker run. I will show you a demo of these things also, don't worry. Then you have to give in the parameters -p, which is 8080 port of the Docker container should be mapped to 8080 port of the computer host system on which the Docker is running, right? And then it will work. 8080 port will work. This is the idea, right? So this is again another thing where we were trying to map the port mappings, and approximately I think we spent some, and port related differences are there, and this mixed with the kitematic problem that Kamal spoke about, it easily cost us like 4 to 5 hours again. This is also. So again, take back our 5 hours so that you don't do this again. Second point, right? And the last but not least, last oops moment or the mess up that we did is we tried to manipulate the env command to set up some environment variables. But since it is within the Docker file, you can use it only within the build time, not the run time. So in the build time, you can probably set it for dev environments, but for prod, you will not be able to do anything. For example, in the env environment dev I am setting here, probably you can get around to dev testing only with this command, but this command will not help you to set any environment for the production environment or any modifications of the image that you want from the image that you initially create. For that, what you have to do is, again, while running the container, docker run -e you have to give. Environment is equal to dev or prod or staging. Assuming that you're using this environment variable inside your application somewhere, you have to use it like this. Then only it will run. This is another thing which, see, we both were reasonably good people in terms of technology. We have had good applications behind us. We have done meaningful applications, but and we have tinkered with the Docker to say that we have touched Docker. But the problem is we did not have much experience in production grade Docker experience, right? And when you actually do production grade products on Docker, these are some things that can save you some time, because we had 10 years of experience behind us. We made these mistakes. So you could make these mistakes also when you are getting started. So we started, what do you say? We have a list of things that we did and we could not have done before. So this is one of such things. So 3 oops and 3 ahas we shared. Now is the time for a demo, right? And this is the place where you can see our demo code. So what I will do is I will first show you this kitematic that Kamal has been speaking about. So this is basically the kitematic UI. From here itself you can create containers if you want. We are not going to do that today. And what I'm going to show you is how this containers list changes as and when I run the Docker commands in my computer. So what I will do is I'll go ahead, and this is a terminal in which I'm going to run my Docker. See, I already CD'd into the folder where I have my source code, right? So if I run pwd, this is the folder where I have my source code. This is exactly same as the GitHub repository that we speak about, right? Maybe I can put that GitHub repository in the chat. Maybe you can take a look at that. Just a second. Okay. I'll just put it in the chat so that, if you want, you can follow it up as and when I speak. This is the GitHub repository, right? So now what I'm going to do is, if I see in my current folder, there is a Docker file. So what I'm going to do is Docker build. I want to create a Docker image of the current project. So what I'm going to do is Docker build, and from which directory I have to build? The current directory. So I put dot, and I want to have a human friendly name for it. So I'm just probably going to call it TAC2020 for now, right? And I'm going to just create an image. So let us see. It did a lot of things. If you see, what it is running is each line from my Docker file it is running from, okay, something happened, run, something happened, workday or something happened, and so on it goes, right? Now, after that, now that the image is created, let me try running it. So Docker run, and what I'm going to run? TAC2020, because that's the name that I gave. But I want to create -p 8080 because I'm exposing 8080 port in my application. Let's see what happens here, right? So I'm just going to run it here. So app listening to port 8080. Now, if you see kitematic, there is somebody here. It gave a human friendly name, leave it. So I'm just going to click here, and you see there is already a web preview loaded saying, hello world, this is a dev environment. And I click here. I don't have to remember the port numbers now. And this is the URL that got opened here, if you see in my browser. Right? Now, this is a dev environment. Now, if I have to run it in the prod environment, what I have to do is I'll go back to this container place, right? I'm just going to exit from here. I'll open kitematic. I'll just mercilessly remove this container. Now done. Everything is gone. Now I'm going to go back to the terminal, and I'm going to run the very same command. But now I'm going to give -e environment is equal to prod and run the same. What I did, I just converted my container into prod. This could as well be the prod environment now, right? Let us see what happens. Oh, I haven't pressed enter, is it? Yeah. Yes, 8080 port, and see some other container has come here. I'm just clicking here, and there is already what do you call this thing, and as usual demo gods did not grant me my wish. This is still saying dev environment. Sorry about that. Something happened to my setup in the Docker images, I guess. Maybe I have a environment. I will not debug it, just you just get the point, right? Environment is equal to prod, it should give you prod. Something is wrong with my setup. So with this demo, probably we thought we could part our ways, and basically a summary of what we did is we spoke about what is technical agility, what is not a container, and what is a container, and a side-by-side difference between VM and a container, and 3 aha moments, and additionally 3 oops moments. This is all we spoke about, right? And now we are open for questions. Maybe there are already some questions in the chat. We'll start answering them. Have you evaluated Google Cloud? Okay, the problem with vendors, most probably I'm assuming that this question comes from the competition between Google Cloud versus AWS versus Azure and Heroku and all these things. We just wanted to get started with something with an idea that something that does not provide us lock-in is okay for us, right? And no matter where we went, we found out that containerization gave us cost benefits. Does that mean that we will not use Google Cloud in the future? We may use. But right now we are going to stick with AWS because right now we are just you can call it even like, we just tossed a coin and said, okay, let's use AWS. There is no specific reason other than the fact that, we have some cost benefits in the first look, and our basic infrastructure or basic architecture is basically not related to any cloud infrastructure at this point in time. The same face recognizer you take and put it in some other cloud, it's supposed to run the same way. We are not putting in AWS specific code in the classification service of our code. That's the idea. Did I answer your question, Naveen? I don't know.
Yeah, Vivek. Yeah.
Oh, okay.
Yeah.
Okay.
Vivek, just before you continue, thanks, Vivek and Kamal. So before we proceed, I just hope that if anyone's having any trouble posting the questions, please look at the bottom section. You should be able to post some questions. At the same time, there's a poll section which has already been pushed. You can also give your feedback. So if anyone has any other questions, please post it so that Vivek and Kamal can address them.
Okay.
There is one question. All applications running in Docker, do they independently consume resources directly from OS or managed by Docker daemon?
Kamal, do you want to take that?
Yeah, so Docker daemon helps in doing software virtualization, right? So Docker containers share the OS kernel of your host operating system, and the Docker daemon is a service which helps doing that virtualization part. Yeah, so they share some part of the host operating system's resource. Hope I have answered your question.
Yeah. So if you have any questions, let us know so that we can talk about it. Yeah.
Yeah, if there are no questions, probably we can summarize.
Yes, we have 5 more minutes. Yes, we can.
Okay, so what we tried to do was to, as I said before, the purpose of this talk is to save you time and thereby saving you some money. So what we did was we took some aha moments which we thought we should know earlier, but we somehow discovered on our journey, and put a time price to it. And also oops moment, which we thought we should never have done in our life, but still we ended up doing and wasted time, put a price to it, and then presented this entire recipe to you so that you can, take that and save some of your time, right? So I'll just summarize what are the things that we spoke about in the aha moments. Cloud vendors love containerized apps. Additionally, if your containerized app is fault tolerant, as in, let's say they can stop the service at any time and still your application will work fine, they basically give you as high as 15% discount on the running cost, and it's worth to do it. That's one. If you're starting out on your applications, you should probably consider that. Second, Devon can be actually shipped to customer, and this is basically a case for Docker if you see, right? Without any problems, you just can manage quality in a better way. And third one is about the Kitematic web preview, which I just demonstrated to you. I don't have to remember the port number. I don't have to remember, in case of boot to Docker, what IP address is assigned to boot to Docker. A lot of trauma. All application. There is a question. All application running. Okay.
Yeah, I think this has been answered.
Okay. Okay. Yeah. Should that be? Is there any other follow up on that? I think the person posted this question is different from the person who asked it. Nashal asked that question and Ganesh posted this.
I think they put it in the chat and they just reposted on questions. Actually.
Okay, fine. Yeah. So, and the oops moments that we came across was, though your Docker file run command will look like a shell script, it doesn't act like a shell script. Each command is an independent unit of execution. So use that with caution. Don't use CDs and assume that it will work. Don't waste time, because it's very difficult to debug when you run into this situation, because you do not know. It will say that the file does not exist, but you will see the file lying right there, and it will say the file does not exist, and that's frustrating. And that the error message does not help you at all. So you just get out of that situation by using cd's inner run commands properly. Expose doesn't do anything; it just is for documentation of the developers. And environment variables can do only so much. You can put only dev environment here, and prod is not there. And maybe since Kamal gave that suggestion, let us probably try doing that environment variable thing here. I'll just try to do that, and with that we can close. I'll just stop the container from here and run it. Okay, my Docker quick start terminal is also misbehaving. Okay, I think we are 4 minutes. Let me see if I can finish the demo by then. Yes. Yeah, cd c users calib source codes TAC2020 demo. Yes, this is the folder that I was in. So in this, I'm going to run docker run TAC2020, but with the ports -p 80. Oh my god, just a second. Space 8080:8080 and -e environment is equal to prod. Let's see if it's working. Okay. And yes, it's right. Kamal's suggestion is right. It's giving me, this is a prod environment. And if you see, the URL is same because I'm just using the same thing. In your actual, prod use case, you would have a different URL, of course. That was also one of the comments that we got. So we are just doing a demo here. So assume that we are doing it in prod machine for the lack of different machines in our system. So demo is also done then. That is all we had. If there are no questions.
Yeah. Vivek and Kamal, thank you so much for the session. It's always good to see someone's experience and learn from them. And as you said, it will always save us some time and money. Thanks a lot again for the wonderful session.
And
Thank you very much,
thanks, team.
everybody.
Thank you very much for the opportunity.
Thank you, everyone. Yeah.
Thanks, everyone.
Bye.
Thanks, everyone.